Hello guys, I am Parinita and welcome back to my channel to polish your CSE concepts with me. So let's get started. In this video we are going to see one topic of compiler design. If you have seen my previous video of compiler design, you must be knowing that what we were doing, we have already started learning about different types of parsers. We have seen which are the different categories of parsers like top-down parser, bottom-up parsers and all, and we have seen just the introduction about them. And in this video, and then I have already told you that in the next videos now what we are going to do is we are going to see each parsers individually in detail. Fine. So today's video is about that only. We have already seen brute force method. Let me quickly revise once so that you will get a clear idea. We have seen about brute force method, recursive descent parser, non-recursive descent parser, operator precedence parser, and then we were having LR parsers. Right. Let me quickly remind you people. So I have told you in that video also brute force method. The first method that we were having under top-down parsers is brute force method. But we are not going to see brute force method in detail because brute force method is not included in our syllabus. And I have told you the reason also. Why? Because brute force method means what? It is not following any specific rule. Brute force method means what? It is kind of try and error method. We will try one thing, if it works out fine, otherwise we will backtrack and we will try something else. If it is working out, then fine, otherwise we will again backtrack and try something else. So this is something we are not going to use nowadays, right? Because it will be an overhead, again and again trying new things, backtracking, trying new things, backtracking. So brute force is something that is not practically used, and so we are not going to see it in detail. Fine. Now my second parser is recursive descent parser. Now if I talk about recursive descent parser, see, we were having recursive descent, non-recursive descent and operator precedence parser. So in these three parsers, non-recursive descent parser, it is also known as LL1 parser, and this LL1 parsing is one of the very important topics of compiler design. So what I have done is, in this video, see, LL1, that is non-recursive descent parser, is a bigger topic and it is an important one also. So I will be taking that topic in my next video. We will only see about non-recursive descent parser. But in this video, we are going to see quickly about recursive descent and operator precedence parser. Because these two parsers are something that is not that important in terms of our normal GATE or BTech MTech syllabus. Normally, from these two parsers, normally questions are not asked. But then also we will see one overview so that in case any question is asked, we should know the overall idea that what these two parsers are about. So in this video, we are going to see about recursive descent parser and operator precedence parser. Fine. So first of all, let's talk about recursive descent parser. What does the word recursive means? You have already seen, we have already studied about recursive functions. You must be knowing at least the word recursive. What does the word recursive means? Recursive means calling itself. Recursive function means what? The function that calls itself. It is known as recursive descent parser. It is known as recursive functions. So recursive is all about calling itself again and again. So in this recursive descent parser, how it works is, as you know, these are parsers. All the parsers are dealing with grammar. So in this case, in this recursive descent parser also, we will be having any such grammar. And what happens in recursive descent parser is, in the grammar, how many variables are there? First of all, we have to check that. Again, what is variable? Mostly the capital letters like E, E dash. In this case, only E, E dash are there. So whichever capital letters are there in our grammar, they are mostly known as the variables or the non-terminals. So what happens in recursive descent parser, that whatever variables are present in our grammar, we have to make a different method for all those variables. One different method for all those variables will be made. There will be something known as match function. There will be one main function, and by parsing, and like this we will be writing whole code. And by parsing our grammar, or by parsing the string with the help of this code, we are going to check that whether that string belongs to our this grammar or not. This is how the whole recursive descent parser works. Getting? We will be having one string. We will parse the string with the help of this whole code, and we will come to know that whether that string is valid for our given grammar or not. Fine. So let us check how the code is made, because that is the most important thing in this recursive descent parser. This recursive descent parser is a type of top-down parser. Fine. Okay. So for example, this is the grammar that is given to us. We have to write a code for this grammar in recursive descent parser, for recursive descent parser. So what we will be doing, as I told, first of all we will be having two methods for two variables, because in this grammar we were having two variables, that is e and e dash. So we will be having two methods. Now for e, the first method will be about the starting symbol. So in this case our starting symbol is capital E. So in for capital E we will be having one function. Inside the function what we are going to do, we have written if L equal to I. Why I? Because this. See, you have to remember this thing, that whenever we will be having this terminal, any terminal, we will be writing L equal to what is L equal to I or not? We are just checking it. What is L? L is my look ahead. Fine. L is called look ahead. What it does, L means it is doing what? GATE CSE. That means it will do nothing, but it will just take the first character from my RHS of the production. Getting? Whenever I am having a production, because my task of this code is what? Whenever I am having a string, I have to check if that string belongs to my grammar or not. So what we will check? We will check that this RHS satisfies the string or not. So for that what we are doing, we are taking get character, means we are taking one by one character from the RHS and we are matching it with our given string. Fine. So first of all what we will do, in case, so we just have to remember two rules, that in RHS if we are having terminals, these small characters or terminals, we will just compare it with our look ahead. Look ahead is what? It is nothing but get character, taking the character one by one. So whenever we are having terminal, we will compare it with our look ahead, and whenever we are having variable, we will just call that variable. Simple. These are the two simple rules that we have to remember, that whenever there is terminal, we will be matching that terminal with the look ahead, and whenever there is any variable, we will again call the function of that variable. Simple. So first of all we are having one terminal. So what our task is, we have to match this, we have to compare this terminal with the look ahead, and then we have to match it. So inside this capital E function, that is our starting symbol, first of all small e, that is terminal, is there. So what we will do, we will compare that if our look ahead equal to this character I, then do what? Then match I. Match means, match is again a function that we have written. In match function what we have done, let's see this also continuously. What is match? In match function we are passing one character, that is character T. This is just a parameter. This will be the terminal that will be coming from the grammar or the string. So this terminal will be passed as a parameter. So in match we are having one parameter of character type, and then inside the match we are just checking that if the look ahead equal to my terminal. If the look ahead whatever I got is equal to my terminal, then simply get character, get it, else printf error, because if they are not matched, that means it does not belong to my grammar. So we will simply give the error. And this is what match function is doing. So whenever we are getting one terminal small I, we are just matching, we are just comparing with look ahead, and if it is compared inside, we will be passing it to the match function. So match of I, and then one variable is there a dash, so we will simply call this variable a dash. We are simply calling a dash. Fine. So this is all about E. Then similarly we have to make a function for a dash. So making a function or method for e dash will be, first of all I am having one terminals plus. So if L equal to plus, I have to compare it, and then I have to call match plus. That is done. Now after plus I am having small I. So I will do match I also. So match I, and then I am having one variable e dash. So after that what I will call, I will simply call e dash because it is a variable. And then we are having what? In OR I am having null. So whenever we are having null, we will just call return. We will simply return without doing anything. So this is e dash gives, this is one production, or this is null. So for or we will be writing else. See, in E dash I am already having this. In E dash I am already having this whole, we have seen this. Else, because it was in or, so else I will just return nothing. Else return due to that epsilon, due to this epsilon or null. So whenever we are having null, we can simply write this else return. So this is all about E dash function. Simple. Now only two variables are there, E and E dash. We have written for E and E dash, and then one match function will be there, as I have already explained you match function. And what is main function? In main function we will do simply nothing. We will simply call E. E is the starting symbol. From main we have to just call the starting symbol. Then what will happen? See how the flow will go. From main I will first of all call the starting symbol. From starting symbol it will call this function. From here it will call the another variable, this. If there had been more variables, then from this variable that will be called one by one. All the variables will be called. Inside the variables functions, this match will be called whenever necessary, and at the end we will get the result. So at the end we will check if my look ahead equal to dollar. What do we mean by dollar? Whenever any string is completed, at the end of the string I will be having dollar. So if my look ahead equal to dollar, that means what? My look ahead reaches up to the end of the string. That means I can say that that given string is parsed successfully. So in the main, first of all I will call E, the starting symbol. From starting symbol all the other functions will be called, and at the end I will just check that if my look ahead equal to dollar, simply I will printf that my string has been parsed successfully. So this is how the recursive descent parser is working. So we have to just remember that this recursive descent parser is all about calling these functions. Fine. So I hope you have understood the flow. In this we just have to understand this flow, that how it works. Now after recursive descent parser, as I have told, we are having one more parser, that is operator precedence parser. This operator precedence parser is also not that important, but in case any small question is asked, these are the only 1-2 points that you have to remember about operator precedence parser. Well, in the previous video also I have told you the most important point of this operator precedence parser, that the speciality of this parser is operator precedence parser is the only parser among all the other parsers that can parse the ambiguous grammar. This is one of the main important question that has been asked repeatedly in various competitive exams, that the only parser that can parse the ambiguous grammar is the operator precedence parser. Fine. So this is the important thing that you have to remember. Apart from that, the other points that you have to remember is this operator precedence parser, its name is like this, like it is called operator precedence parser because it is mainly used to define mathematical operators for the compiler, as the name itself indicates, right? There are certain restrictions on the operator grammar. These restrictions are again one of the important things to remember. There are certain restrictions on this operator precedence grammar, and the restrictions are two variables cannot be adjacent to each other, and second, there should not be epsilon on the right hand side. If there is any grammar given, actually this is a GATE asked question also. In GATE and I guess in UGC net also this question has been asked, that if for example they are giving 3-4 grammars and they are asking you that which of the grammar are operator precedence grammar and which of these are not operator precedence grammar. So how can you recognize them? If two variables are adjacent to each other, we can say that it is not operator precedence. If there is epsilon on the RHS, we can say that it is not operator precedence parser, because these are the two restrictions on the operator precedence grammar. So for example, these are the 3 grammars, consider them 3 productions. If these 3 productions are given and asked that they are in operator precedence or not, what we can say? In the first case, S gives capital A, capital B, D. Is it operator precedence grammar? No. Why? Because A and B both are capital, means both are variables, and 2 variables are adjacent to each other in this. But we have in the restriction we are having that 2 variables cannot be adjacent to each other. So in this case my first condition holds false. So I can say that this is not my operator precedence. This cannot be the production of operator precedence parser. Then second is S gives A, B, D. Can it be operator precedence grammar, operator precedence parser? Yes, because two variables cannot be adjacent to each other. Yes, no two variables are adjacent to each other, and there should not be epsilon on the RHS. Yes, there is no epsilon on the RHS. But if I talk about again the last one, that S gives epsilon, it cannot be, because obviously again the second rule is violating, that there should not be epsilon on the RHS. But in this case there is epsilon on the RHS, so I can say that it cannot be a part of operator precedence parser. So these are some of the questions, small questions that are asked based on these two parsers. So I just wanted to give you an overview of these two parsers in this video. So these parsers are not among the very important parsers from which many questions had been asked, but these are some overview that you should be knowing. And in the next video, as I told, we will be learning about LL1 parsers and all the LR parsers, which are really important in terms of our compiler design syllabus. Fine. So from the next video we will be seeing those things. So guys, that's all about recursive descent parser and operator precedence parser. I hope you have understood that. If you think that my video was helpful, please subscribe the channel and let me know that you really liked it by liking the video and leaving your comment. Thank you so much.